So here we're going to take another look at the unit cell. We have another video where we look at the material polonium because it's a little bit simpler and an easy one to start out with. We're going to look at something a little more complex here. Here we're going to look at sphalerite, zinc sulfide, and I have a diagram here from Dexter Perkins' online textbook on mineralogy that shows the unit cell for sphalerite. So we're going to look at calculating the unit cell for this. This diagram here, it's kind of nice. It shows us the C, A, and B axes, their orientation in their classic sense, and he also has numbers here that refer to the coordinates. We're not going to worry about the coordinates so much as we're going to use this equation that we showed in a previous video, where Z, the number of formula units in the unit cell, is equal to density times volume times Avogadro's number divided by molar mass. So for the case of sphalerite, its density is equal to 4.09 grams per cubic centimeter. The edge, the size of that edge is, as we go from, let's say, the top right corner there and then to the back corner there, that cell edge would be, let's just call it A, and it's 0.541 nanometers, and that's equal to 5.411 times 10 to the minus 8 centimeters, and we'll just put another 1 there to be consistent with the significant figures. And so that means for the volume, we would take this and cube it. And so the volume of sphalerite, the volume of the cubic, this unit cell here, would be 1.584 times 10 to the minus 22 cubic centimeters. And then that whole thing would be multiplied by N, which is Avogadro's number, 6.022 times 10 to the 23, and then it would be divided by M, the molar mass, and the molar mass for zinc sphalerite is 97.474 grams per mole. Let's take care of the units here. They should all cancel out and give us a pure number here for Z. So we have grams on top. That'll cancel with grams. We usually talk about Avogadro's numbers being unitless, but it's also numbers per mole, like having 12 per dozen, for example. So we've got a 1 over mole here and a 1 over mole here after we cancel out the grams. And then cubic centimeters and cubic centimeters cancel, leaving us with just a pure number, and that pure number is Z is equal to 4. So Z is equal to the number of formula units. So we have 4 formula units per unit cell. That's what that Z means. So per unit cell. If we have 4 zinc sulfides, so then that must mean that we have 4 atoms of zinc and another 4 atoms of sulfur. And this is why this diagram from Dexter Perkins is so handy. This would be terribly difficult for me to draw, but he has here very nicely labeled the zinc atoms in a blue color and then the sulfur atoms in kind of a reddish color, a little bit larger. And so now we could start counting the atoms. Now, if you looked at our video on polonium, you know that this fellow over here on the corner only counts as 1/8 of an atom because there are other unit cells that are emanating from here. You can consider 4 boxes down here and another 4 boxes on top. So there's 8 boxes, 8 unit cells in total that atom is being shared with. And so that means it only contributes 1/8 of itself to each of those unit cells. So if you've just got 1 atom per 8 unit cells, then that would be 1/8. And we've got 1/8 of an atom there, another fellow on the corner here. We've got 8 fellows on the corners. So with 8 corners times 1/8, that is equal to just 1 atom. So those 8 atoms on the corners just add up to 1. Well, that takes care of one of the zincs. There are 4 zincs. Where are the rest of them? Well, look at the fellow here in the center. So that we have 1 in the center of the face there, 1 in the center of the face there. There's 1 at the face that's in front of us. Altogether, We can connect these with lines. It's not a very straight line. There we go. So top and bottom, left and right, front and back, and then all together we have 6. So we have 6 atoms, but how are they being shared? Well, this atom here is going to have another unit cell on top of it, and so this fellow in the middle of the face will be shared by 2 cells. So it's 6 times 1/2. That is equal to 3, and 3 plus 1, when we add those together, those are our 4 zincs that we get out of the 4 formula units per unit cell. We should also have 4 sulfurs, and those are the easy ones. Here's the sulfurs here, 1, 2, 3, 4, and they are contained completely within that box. They're contained completely within that unit cell. They don't belong to any other unit cell. They're not being shared with another unit cell. And so all 4 of those sulfur atoms all belong solely to that unit cell and nowhere else. So we have 4 atoms in that unit cell, 4 atoms of sulfur, and sure enough, that's what we get out of our calculation for Z. So we've accounted for the 4 zinc atoms. There's 8 on the corner that are being shared 8 ways. So that adds up to 1. And then there are 6 on the faces. Those are being shared by 2 unit cells. So those add up to 3. That's our 4 zinc atoms. And then our 4 sulfur atoms, when we just count them up, they're all inside the unit cell, so they all count as 1 each. So those are our total of 8 atoms that are in the unit cell, 4 zinc, 4 sulfur in this, and we might as well finish this off. This is a face-centered cubic type of arrangement, or we can just abbreviate it as FCC.